Good morning, ladies and gentlemen. We will start our webinar with today's topic, 1500 volt modules, the benefit and challenges. After the session, we will send the PDF, so the presentation and the recording around, and we'll put as well the recording online. The duration of the webinar will be approximately 30 minutes. After the presentation, I will take a look on the question pane, and under all the open questions. So please use the chat or the question pane to place your questions during the session, and after that I will check. Today we speak about, or the agenda for today is, I give you a brief introduction about the background of 1500 volts. Then I speak about the benefits, then as well for about the challenges, and give you afterwards a brief summary to sum up the findings we get during the webinar. What is the background? The background is first that the industry is thinking about to upgrade the system voltage. As you may know, US already did it from 600 volt to 1000 volt. Even if according to Yale 600 volt is the limit, but then behind the fence they already made 1000, what was according to IC, and they also switched to 1500 volts. Even for Europe, there's a question, why not 1500 volt? Because we have a low voltage directive, and inside the low voltage directive there is a voltage limitation for the low voltage by 1500 volt, and the IC only goes to 1000 volt. Though there was a question in the past, and why not going to 1500 volt, because it's already allowed in the low voltage directive. Some of the ones already mentioned here, for example, that the increase of the string length and the decrease of, for example, combiner boxes and stuff like this, or circuits, parallel connections, the increased output voltage of the inverter to have a higher input voltage of the inside to the transformer. What is a clear benefit if you want to step up from, let's say, it makes a difference if you want to step up from 400 volts or 600 volts to, let's say, 6,000 or 20,000. Later I will also show you some impacts based on this, and we will also speak about the costs and the differences between the systems. In today's session, we will always have a look on this sheet, on this pie chart. The pie chart explaining the LCOE. LCOE is the levelized cost of energy, and the LCOE can be split in terms of cost into different categories. We have here, the first category is BOS, balance of system fixed. The BOS variable. Fixed cost, if you have, for example, a utility scale plant with a size of 10 megawatt, then the fixed cost would be, for example, the inverters, the substation, or the transformer. If you take a look on the variable BOS costs, they are typical cables, then combiner boxes, substructure, and so on. Then we have as well the module. The BOS plus the module give you the capex, the investment. The financing, for example, depending on variable on the bankability of the components. Then the OPEX. OPEX is operation maintenance costs. It's also dependent on the system design, for example, the quality of the single components, and then we have development costs. The development cost is mentioned here as staff. For development, for example, the project development for utility scale projects. What are the benefits? We directly start with the benefits in terms of cost. So here we have a graph from GTM, from Green Tech Media, showing an example for the US. Here we have let's say a space, a 1000 volt system with cost of $1.7 per watt. Then If you increase the system voltage, then for sure the modules get more expensive because they have to fulfill higher requirements in terms of, for example, isolation of the backsheet, isolation of the cabling, different connectors and so on. Then we have the inverters. Inverters are there. The inverter manufacturers are not really consistent in their statement if the inverters gets more expensive or if the costs are equal or can also be reduced. Here it's assumed that the inverter costs are getting a little bit more expensive. On the cabling side, there will be a reduction. The reduction comes because we have longer strings, less parallel connections, and that means less cables, then less combiner boxes because we have less parallel connections, which is reducing the number of combiner boxes, and then there's the labor. Why labor? Because basically it's easier, you have less cables to pull, you have less combiner boxes to install. All overall, even with the increase on some components and the decrease on others, there's a total advantage of 2 cents. What are the savings? That means even in a country, or even if you have higher system costs, you see that the savings are there, and with a 1500 watt system there can be savings on the capex on the investment side. Now I want to show you two different examples. The first example, it's still here with the system costs here marked as green. Here we have comparing a 1000 volt module framed versus a 1500 watt system framed. You can see that module costs, it's harder to see, but the module costs a little bit more expensive. You clearly see the savings for the cabling and electrical connections. Substructure, for example, and the mechanical installation for sure is not touched. Here the savings on the electrical components is approximately 33%. This leads to a savings of approximately 4 cents, as 4.3, which is 4.7 relative, and based on L3 calculation for a European country, there we can reduce L3 approximately 4.9%. That means if you're comparing a 1000 volt system compared with a 1500 volt system, the 1500 volt system, even with more expensive components, will lead to cost advantage on a system level and on the capex level, which leads to lower L3 and an increased profit. Now I want to also show you the differences between the cost savings differences between a framed module, the framed 1000 volt module, and a 1500 volt frameless module. What can we see? If you take a look on the graph, you can see that the frameless module is a little bit more expensive to install, depending on the solution. For example, if you have clamps and it's a little bit more time consuming, the module needs to be handled a little bit more careful. The savings on the electrical side will be the same because from the electrical properties there is more like no differences between a framed and a frameless module. And though overall the savings are still approximately 2 cents, but the advantage of the frameless module is a better reliability and the lower degradation, which I will show you in detail later. So if you take the advantages of a glass-glass module into account, the LC reduction will be more than 5% and even higher than compared with the framed modules, even without reducing the risk in terms of, for example, degradation. What can be also said about the performance improvement? The performance improvement, one side could be the inverter side. For the inverter side, I would say it's not really given. The examples I looked up there, the efficiency of a 1000 volt or 1500 volt system are usually equal. Some inverter companies say that the efficiency can increase. If the efficiency increases, then this is a clear benefit for the energy yield. For the cabling losses, for the cable sizing, this can be calculated. I have calculated here on the right side. So if you have here the 1000 volt system compared with the 1500 volt system with the same cable cross section, then you can see that the cable loss gets reduced. Though in the string cable case, it's quite small, but it's still there. And for the home run wire, it's approximately 0.14%. And that means you have additional energy what you can use to feed it into the grid. That means you can increase slightly, even if it's slightly, but even penny counts. You can increase your energy yield and increase your profit and reduce your levelized cost of energy. If we now take a look on the operation maintenance. The operation maintenance, it's basically, for example, checking the components, which you have to do frequently, one time per year or every 6 months. And with the example here that I have used a 10 megawatt plant, then we have here for the 1000 volt system we have 2 megawatt inverter stations. For the 1500 volt it's one inverter station less because the size is 2.5 megawatt instead of 2. But the bigger impact is here on the combiner boxes, on the monitored one. Here in the 1000 volt system you have 76, and on the 1500 volt system you have 50. As you can see, the number of modules is still the same. If you calculate then the benefit in terms of operation maintenance cost is that you have approximately 4% benefit. The warranty. As discussed before, the Duomax, the glass modules, has better performance warranty conditions. You can see here the gray area is a conventional friend module with the degradation of 0.7% per year annual, and the blue one, that's the Duomax with the reduced degradation of 0.5%. Why can the degradation be, or the warranty degradation can be reduced? The advantage, or one of the biggest advantages of a glass module is that the cell is in the middle between the two glass sheets. That means that the stress on the cell is lower. Since the cells are stress sensitive and can break or crack under the stress, it makes sense to place them close to the neutral phase, what is the case in the glass module. That means the risk of having micro cracks is way reduced. The further advantage is the PID. The potential induced degradation is also depending on the system and module design. And later I will explain more about the PID in more detail and the effect. So the PID is reduced, the risk of cracks, also of micro cracks, is reduced. That means a lower annual degradation. This leads to an advantage. If you take a look at the endpoint of the single warranties, that means after 25 years for friend one, we are at 80.2% approximately, and with the Duomax after 30 years, so 5 years more, with the lower degradation, we end up at 83%. Taking all this additional energy into account, the higher secureness of the product, so the higher reliability, the higher durability, then we can increase our profit by approximately 5% based on the lower degradation and based on the advantages I already showed in terms of system costs and the additional energy here again generated by the glass module. What can be done else? Another idea is to work on the concept of the plant. That means on the inverter and transformer concept. Here are displayed 4 different cases. Case A is the known one with a 1000 volt system with an output voltage at the inverter side of approximately 360 volt. Then the increase to 1500 volts leads to an output voltage, or the output voltage can be then increased to 570. The concept C and D are showing further option with B polarity to further increase the output voltage. Why can it be important? If you take now a look on the transformer, the transformer usually is limited based on the information I got from a manufacturer on the current. The limit is at a current of approximately 6,500 amperes. If we now calculate the maximum size per case, then in case A, with output volt or with an input voltage of 360 volt AC and an output voltage of 20 kilovolts, we end up at a size of 2.3 megawatt ampere. In case B, with an input voltage of 570, we end up at a size of 3.7 megawatt ampere, and for C and D it's 6.5. If I now go for take a look on a utility scale project. For example, if I have a 50 megawatt project and only comparing case A and B, those are upper twos, then in case A 22 transformers are required, in case B only 14. That means that the installation effort can be reduced by approximately 36%, what is a clear benefit, especially if you have extreme large systems. What are the challenges? Because if you speak about benefits, we also have to take a look on the challenges. One of the challenges is the availability of the different products. So for modules, this is quite improved. For connectors, it's okay because it's also known in other branches. Cabling, for sure, that's no issue. Combiner boxes, disconnects, especially made for PV. There, the available one is limited, but the techniques is known based on other branches, for example, in the railway or train section, and for inverters. If you take a look, for example, or if you want to look for string inverters in a small size, there the number of available products is very limited. It's only a few available. And note, for example, that Sungrow is starting to offering, or Huawei, and there the size is starting from approximately 30 to 40 kilowatt up to 120, 150. And for inverter stations, there the number of available products is higher, and there the size is more over 2 megawatt. Here's an overview for module. As I said, it's already improved. So for example, Trina is offering the complete product portfolio. They're all framed as 1000 volt or 1500 volt version, and all the glass modules which Trina is producing, there's a complete Duomax series in polycrystalline and monocrystalline, is only available for a system voltage up to 1500 volt. Though the module availability is quite good. There's additional costs there. For details, I would recommend to ask our sales. What are the additional costs? They know it in more detail. If you take a look on the inverter side, this is something between, I would say, red and yellow. It's still limited, but the number gets increased. As you could see, the connectors, cabling, wire harness, combiner boxes. Combiner boxes is also increasing, but for example, the cabling, you see, it's no issue. What is also important to know is the requirement on the monitoring system. What is displayed below? Because you can see that if you have an impact on one module, for example, the voltage drops or the current drops, this effect cannot always be seen in a complete, or you need a better monitoring system for a system operating on a higher system voltage, because the relative loss for sure gets reduced because the steering length increased. Now we want to speak also about the PID. What is PID? PID is potential induced degradation. So you have an electrical field, or you build up an electrical field as shown here in the picture, between the active cell and the grounded frame. The frame needs to be grounded and is grounded with the substructure. The effect increase if you're close to a sea, especially with the salty air, or in a tropical area, so hot and humid. Why hot and humid? Because the absolute humidity is higher if you have higher temperatures, even if the relative humidity is the same. If you take here a look on the analysis of the PID, though here we have a module without PID cell, without anti-PID cells, then we have a friend module with anti-PID cells and a Duomax. All our cells or all our modules are produced with anti-PID cells. So we only need to take a look on the last two. But even if you compare the friend one with the Duomax, you can see that the glass module is more than halved in terms of the degradation caused by PID. Why is it? If you take now a look on the module and the electrical field, if you have a friend module here on the left side, the friend is going all around the module. So you have a closed loop, and that means you can build up an electrical field over the complete module, because you have all around, you have a conductive surface, and the conductive surface is quite narrow to the cells. With a frameless module, you have higher distance between the active cell and the next conductive part, the clamp, for example. Or if you have other solutions what are bonded on the backside, that's even better, because the distances are further increasing. If you have a clamp compared to a frame, as I said, the frame is going around the complete module. A clamp usually has only a length of 80 to 200 millimeters, and you have 4 to 6 clamps per module, though the metal area, what is the conductive part, is quite small compared to a friend module. That means the electrical field cannot build up like on a friend module. If you don't have the electrical field or the strength of the electrical field, then the PID effect is reduced. That means a frameless module based on the design, especially for higher voltage, because the PID effect is also dependent on the voltage level, is way better than a friend module. So if you're looking for products for long-term behaviors, or 25, 30, and even more than 30 years, you should take a look on a glass module to have the best reliability you can get. Now I want to sum up. First of all, again, the benefits. The electrical components like combiner boxes, parallel cables are reduced by approximately 33% based on the longer string. The string lengths increase by approximately 50%. The higher system voltage the advantage of higher system voltage is that the output voltage of the inverter can be increased, which leads to the fact that the transformer can be selected on a bigger side, because the maximum current what is limited, let's say the differences in terms of voltage between 400 volt and 20,000 is bigger than between 570 to 20,000 volt. Then for sure the advantage of having different power plants concept for further reductions, and the reduced operation maintenance cost based on the lower number of components. The challenges is the product range for inverters and for combiner boxes, even if the techniques is known, for example, in the train or for trains or for the railway industry. The risk of PID due to the higher system voltage, but this is depending, as I said, it's depending on the location, and also depending on the location, depending on the system design, and The limited experience, especially now in Europe with 1,500 volt system. US and Asia was more open to 1,500 volt system and already have installed some. In Europe, the number is still quite limited. Then the accuracy of the monitoring system to see model function. So you need to invest into a better monitoring system to see if you have defects or if you have modules which are not working or components which are not working on a good level. For example, with some module mismatch, even for optimizing. Or if you have a malfunction inside the combiner box. If you take now a look on the levelized cost of energy on the sensitivity of the LC. Here we have a value of approximately 9 cents. This is, let's say, calculated based on a defined system cost and a European, though here I took Zurich for the irradiation. And if we have now modules in a good quality, so the number of exchanges are reduced, and you see you can decrease by approximately 0.5 cent. If you buy low quality product, it doesn't matter if it's module, it also applies to inverters, combiner boxes, or cables, then you also can increase the LC, what is reducing your profit. Then the energy yield. There, the energy yield is based on, for example, how much uptime or downtime you have. So lower downtime is better. How much energy get collected by the modules, and what is which performance does the module show in the field. And as already shown with the warranty, the yearly degradation. The yearly degradation gives here the biggest impact on being negative or positive. That means if you take a look, it makes sense to invest into products. So in this case, in the Duomax, with the low degradation to increase your profit by reducing the LCOE. Now I want to go back to the graph I showed initially to show the impact on the different categories. Though we had the fixed BS, we spoke about the fixed BS with the inverter concept, we spoke about the variable BS cost, for example, the cabling, combiner boxes, we spoke about the module. Why it gets more expensive? Because, for example, you have to invest into better material for the backsheet because it has to resist and isolate against higher voltages. The same applies for junction boxes and connectors. Then also operation maintenance. What is the impact? As you can see, we have here on the balance of system side, we have here a reduction by approximately 5%. For the variable costs, we have 9 to 10%. The module costs increased by 2 to 5%, and the operation maintenance can be reduced by 4 to 5%. So all overall, the relative reductions are overruling the increase of the cost. On the module side, for the fixed BS cost, it's basically the number of transformers versus as a number of transformers and inverters versus the additional cost. So if you have to buy 4 instead of 5, you have 1 inverter station less to install, and especially in countries with high labor cost, reducing the installation cost is key to have the best or to get the best out of the power plant. As already said, we have different kind of products. So all our friend modules, doesn't matter if it's a 60 cell, 72 cell, polycrystalline or monocrystalline module, everything is available as a 1000 volt system or module or 1500 volt module. And then we have frameless modules. It's a Duomax series. This is available in polycrystalline one, monocrystalline, and a 60 and 72 cell product. And the Duomax has, as all our Duomax have, a certification for up to 1500 volts. I want to say already thank you. I will now take a look on the questions. Okay. Though, for example, one question what raised is in terms of safety in the field. So what happened if you have, for example, an isolation fault, or if you have fire in the field? I mean, you have to state that your workers are operating in an environment with voltage, so with electrical components. And for example, the fire workers, they are trained to how to extinguish, for example, fires in electrical or on electrical components. That means this is already known, because if you're, for example, in a nuclear power plant, or if you're in a coal-fired power plant, they also have areas where you have to deal with higher voltages. Those is already known. And for ground mounted, for sure, you have to make sure that person who don't know about the techniques that only electricians can access, to be on the safe side. But this you have to do anyhow. It doesn't matter if it's a 1000 volt system or a 1500 volt system. And then another question was issues with, or known issues with grid switching or combiner boxes or stuff like this. There we need to say that 1500 volt is not new, as the same for safety. It's already known from other branches, and though it's a known technique, though we can go on and using the limits are already given in the low voltage directive and go up to what is allowed in the low voltage directive. There's a question, what are the physical differences between a 1500 volt and a 1000 volt module? There we have to speak about the framed one. Those differences are the backsheet. Though for 1500 volt module, you require a thicker backsheet to ensure the isolation. Depending on the cable, those are cables coming or going out from the junction box, are usually slightly thicker, but this depends on the standard, what is the newest thickness, or if it's already covered Those differences are the connector, the isolation in terms of thickness or material, the same for the connector, the junction box, basically the junction box material, and the backsheet of the module. That are the major differences between a 1500 volt module and a 1000 volt module, which also leads to the slightly higher cost, because as we know, more isolation, more material is more cost. There's a question about how we prevent water ingress on the glass module without a frame. Basically, it's sealed. Though we have, based on the lamination process, it's completely sealed until the edge. And in the latest one, it's mainly done for to protect more the glass edges. There's an additional so-called edge banding on. That means it's a small foil layer, and this foil layer will be used as additional sealing as well. That doesn't mean with the edge banding that you have to, or that you can store the module, for example, on stones. But secondly, besides the improved protection, it's also better sealing, and though in terms of reliability, even if you look on EL, the framed modules are on the same level or even better. There's a question, the standard DC cables available in the market to date are suitable for these voltages as low temperatures in case of open circuit. There I would recommend to speak with the cable manufacturers, especially for the string cables. The material we are using are designed for operating temperatures from -40 to up to 85 degrees. Low temperatures, so -40, you can find it in Europe, but there you have to go very north, or you have to go deeply into Russia. For the main part of Europe, let's say -20 is already quite low, but the material is designed for low voltage, for lower temperatures. And for string cables, the best to speak with your cable distributor, with the cable manufacturer or distributor. Basically, because PV is not the only application outside, there are cables available which can deal with low voltage, and even for the open circuit case. There's a question about my opinion, if it's possible to find a fault in a 1500 volt system with a monitoring system on an inverter level and not check on the string level. That's hard to answer. So basically, I would say the monitoring system inside the inverter is quite limited, and even the accuracy or the uncertainties you can expect from an inverter measured value is higher than for a string measured value, and even for the special design monitoring boxes. But if you have string inverters with only a limited number of strings connected, so let's say only the small ones where you have, let's say, 4 to 6 strings connected to 2 to 3 MPPs, there it can be possible. The question is, what is the inverter design behind to detect minor differences? For bigger power plants, I would say it's not accurate enough, because you also want to have an early warning, and in some cases you have to ask yourself, then, is it already a malfunction? Yes, no. Is it only difference based on the measurement, or is it for example, driven by the irradiation? Because even the irradiation is quite different. That means if you want to monitor, you also need irradiation sensors with a certain accuracy, that you also know what happened during this time, so that you know, I have this irradiation, though the energy coming from the sun, this is collected by the panels and then transferred to the inverter. And for this, you require more accuracy monitoring system than what usually inverters can deliver. Though the recommendation is that it's better to use external or additional string monitoring. This question about how many systems are installed, also how many systems are installed, it's a little bit hard to say, especially for Europe. I would say for Europe it's only a few. We know that that a few are in discussion. They are more in Asia and China. in Asia or US, but I don't have a complete number about what is, let's say, available as references and how it can be used as record for bankability. This may have to be discussed then with the bank who wants to give you the finance to see how much is required, and then you can go to our or ask our sales team, and then we can discuss and speak also to our colleagues in US to find how many we already have installed. But even if you look, for example, to international reports like GTM, the Green Tech Media, I mean, this is basically for US, but there's a clear trend that more and more systems will go to 1500 volts. There's a question about the reliability test, and based on the time, I would say under one or two further questions, and then the rest will be answered later in the follow-up. There's a question about the reliability. The reliability, what we do in-house, we do more than 30 reliability tests in-house, and we go far above what is required by the IEC by 2 times, 3 times, or even more. And for sure the product will be also placed outside, and we also have, for example, projects running under our hand where we can see the performance. There's a question about how long it will take for the availability of 1500 volt inverters. There's a number already available. There will be, I would say the 1000 volt and the 1500 volt will exist, but I would say, or even if you look on the reports, there's a clear trend that within, let's say 2, maybe 3, or let's say within the next 2 to 5 years, for utility scale projects, the main system will be, according to the reports, 1500 volts. Okay, for the remaining question, we will download them, though even if you have more than write it, and then we will send it in the follow-up email. We also will send in the follow-up email the presentation and the recording in the next days. Thank you very much for your time. Have a nice day.